We go on to the next problem, problem 15. The problem says, put the positive integers 5 to 9 in the product ABC times DE so that the product is as large as possible. All right, so what is the problem? The problem is to put the numbers 5 to 9 is 5, 6, 7, 8, 9. Okay, there are 5 numbers and there are 5 syllables here. So you put those 5 numbers in between here. So you want the product to be as large as possible. Okay, so where do we start? You got A, B, C, that's a 3-digit number. You're going to multiply that by DE. And when you do that, you will see that the A is in the 100th column and the D is in the 10th column. So you want AD, the product here, to be as large as possible. Okay, so firstly, you want AD to be as large as possible. Sorry. Okay, so that means that AD must be 9 and 8. That's the only way you can get that. 9 times 8 is 72. That's the largest possible product that you can get. But we don't know whether A is 9 or 8. A could be 9 and D could be 8, and vice versa. All right. Likewise, you want B to be next in line. Right? Because here you got B has to be 7. Because anything smaller, you could put 5 or 6 here for B. You're going to get, for instance, you're going to get a smaller product. So the largest possible product will occur when B is 7. So what do you have? You have 9, 7 times 8, or you have 8, 7 times 9, like that. Right? But this will give you work this out, you get 776 some stuff plus some stuff. And here you've got 783, 87 times 9 plus some stuff. So you can see the 87 beats that configuration. So we've got 87 blank, and you got 9 blank. That is going to be your largest possible product. So what do you put here? Do you put 5 or 6 here? All right, you can try both of them, 875 and 96, or you can try 876 times 95. Okay, so which of these is bigger? Well, you will see for a start, you got 6 875s added to 9 875s, 9875. So 6 times 875 in this case, and here you got 5 times 876. And clearly, this thing here is bigger. Right? You can either multiply it or you can say you got 5 876s and you got 6 875s. All right, so the answer is 875 times 976. So that is the answer to the problem. 875 times 996 gives you the largest possible product. There's no need to work it out. We just wanted to know which gives you the largest possible product. The next problem says, if we place a 3 at both ends of a number, its value is increased by 3372. The question is, what is the original number? Okay, now we don't know how many digits that number has got, but let's just take a try with 3 digits. Suppose the number is a 3-digit number. I'm not going to put them down, but I'm just going to write a 3-digit number. And you put 3 at both ends in front of the 3-digit number and at the back of it. Its value is increased. In other words, if I subtract these two, right, my answer is going to be 3372. Sorry. 3372. Now, that means that when you add 3372 to this 3-digit number, you're going to get a 5-digit number. That's impossible. If you add 3372 to 3-digit number, you can never get a 5-digit number. Right? It'll still be, it'll be a 4-digit number. Right? Because you got 3,000. 3,000 plus a 3-digit number is less than 4,000. So you can't have a 3-digit number, the original one. Not possible. So your original number is a 2-digit number. I put 3's in front of it, and I have the same 2-digit number. These two are the same. And when you subtract it, you're going to get 3, 3, 7, 2. Right. 3 minus what is 2? The only thing that can go there is 1. So this has to be 1. And therefore, this number here is also 1. Because it's the same number. So that number is 1. Okay, so you got 3 minus 1 is 2. What goes here? 1. So in other words, you have to borrow something from there. It looks as if you're going to get a 4 here. Okay. So and this is also a 4. And if you check it out, if you subtract these two, you'll see you'll get, this is correct. So the question is, what is the original number? This was the original number. The answer is 41. And the last problem we are going to do is this one, which says, that the sum of certain integers is found to be 2643. All right, so you're adding several integers and the answer is 2643. It was discovered later that the digits of one of the 3-digit numbers in the sum was reversed. And the question is, which of the following is a possible correct sum? Okay, let's analyze this. I'm going to take integers now, and I'm going to add them. So there's the first integer, that one, that one, that one, and keep adding them. And we found that it is given that this sum here is actually equal to 2643. Now, it was found later that one of the digits of the number was actually reversed. So all these are the same, but one of them, a 3-digit number, okay, let's call that 3-digit number ABC. So what happened was, the person wrote this number down, they reversed it. So they wrote that instead of ABC, but all the other numbers are the same. And now when you add this, we don't know what you get. You get that's the correct answer. This is the incorrect one. And because this was the wrong total. One of the numbers was reversed. Okay, so this is a correct total. So what can we say? The thing about this is that when you subtract these numbers, let me subtract these numbers, x minus this answer and that answer. So what do you get? X minus 2643 right, is equal to this minus this, which is 0. It's the same number. Right? So here you get 0. All these are zeros. So to subtract this minus this is the same as saying it's that minus that, plus that minus that, plus that minus that, same thing. But here now, you've got, when you subtract here, you get 100A plus 10B plus C. Right? So this is a 3-digit number. So the A is in the hundreds column. So there are so many hundreds, A hundreds and B tens and C ones. So, and you're subtracting that one, which is 100 C plus 10B plus A. So when you subtract these two, this is what you get. So x minus 243 is this minus this. All the others are 0. So you subtract those two. So what do you get? You get 100 A plus 10B plus C minus, put this in brackets, 100 C plus 10B plus A. Now the 10B and minus 10B cancels, and you get 100 into A minus C, 100 A minus 100 C, plus you get C minus A. Now this is just minus 1 into A minus C. So this is equal to 100 into A minus, oh, I'm sorry. I don't want to do it like that. Yeah, let's not do it like this. When you subtract these two, 100a minus a is 99a. When you simplify this, you get 99a. 10b minus 10b goes off, and c minus 100c is minus 99c. And interestingly, this is a multiple of a minus c, 99 into a minus c. In other words, when you subtract these two numbers, the correct answer, minus 2,643, you are going to get a multiple of 99, right? And these are the possible values for x, the correct sums. They say the correct sum, they tell you which of these is a possible correct sum. So what I did was, I said this is a possible value for x, and you calculate x minus 2643, that's what I've done here, right? And I try to see whether it's a multiple of 99. Now, I've done that in all these 5 cases, as you can see, right? And this was not a multiple of 99. It's a multiple of 9, but not 99. This, yes, it is. This certainly is not. This is not. So this is the only one which is a multiple of 99. So the x is actually 2742. And that is the correct sum. X is the correct sum. So which of the following is a possible correct sum? Okay, so that brings this discussion to an end. I gave you some important instructions earlier on. Please follow them. Thank you for your attention.